This is a question of hydraulics, and you can see that there is a smaller piston connected to two larger pistons. So in part A, you are to first calculate the pressure in the oil, which is we'll start from here, and the pressure in the small cylinder labeled as P subscript small is force over area, and we are given that the force is 12,000 Newton, and the area of the smaller piston is 0.048, so we can get a pressure of 250,000 Pascal accepted at this point, which is the pressure of the acting on the oil. Now in part 2, again by Pascal principle, when you exert a pressure on the smaller piston, this pressure is transmitted undiminished throughout the whole hydraulics to the largest cylinder here and here. So pressure at the small side equals to pressure at the bigger piston. So with this, plugging in the formula of pressure equals to force over area, we can get the force at the bigger pistons to be 35,000 newtons. And in part B, to explain, basically use Pascal principle apply to this scenario. So when we exert a force on the smaller piston, there's a pressure exerted on the oil. This pressure is transmitted undiminished throughout the whole hydraulic system. And on the right side, the same pressure will result in a greater force because the area here is bigger. And this is how we can amplify the force on a larger piston. It's interesting to note that even if we connect, let's say 1,000 larger pistons on the right, each of these larger piston will see a force of 35,000 newtons. Of course, there is we can amplify the force like this, but there is always a trade-off, and the later part of the question in part D will allow you to see what is the trade-off when there is many of these larger pistons. Now in part C, you are asked to determine what will happen if there is a leak in the hydraulic system. Now, when there is a leak in the hydraulic system, the pressure that is transmitted throughout the oil will not be the same. It will diminish as we move towards the larger piston, because the actual pressure created here when it's being transmitted throughout the oil, when there's a leak, some of the oil will be pushed out because of this pressure. So there's this loss of pressure whenever there's a leak. And when the pressure on the right is smaller, then the force on the right side will also be smaller. Now in part D, we are to determine the distance moved by the piston, and as explained in class and also in the previous question, there are two ways: conservation of energy using work done, or my preferred method would be the volume displaced on both sides will be the same. So I will use the volume displaced. Whenever we push down on the smaller piston, we are pushing away a volume of oil that will be pushed towards the right side. And the volume of oil displaced on the left will be the same as the volume of oil displaced on the right, which is the volume of oil displaced in the larger piston here and the second larger piston over here. So we will get this, formula that the volume displaced at the smaller piston is equal to the volume displaced on the right side. And since there are two large cylinders on the right side, there are two terms over here, and therefore you can now sort of see the trade-off of having multiple large cylinders on the right. While we can amplify the force on the larger cylinders, the more of these larger cylinders we have, the 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 volume of oil must be shared across all these larger pistons. This will mean that when we have more larger cylinder and piston, the distance moved by each of these piston will be very, very small. and that is the trade-off for having multiple larger cylinders, even though we can amplify the force successfully. So plugging in the values, taking note volume of oil displaced is the area times the distance. That gets us the whole cylinder volume of the oil, and plug in the values and we get 0.011 meters as the distance moved by each of these larger piston.